All right, you guys. Just got off the phone with J-Lo. Goobers. That's all I have to say about that. Just goobers. This video, we're going to be talking about optimization. So what optimization is it's essentially finding the max and min, trying to maximize things or trying to minimize things. So just making them the most, right? If I am trying to optimize how much material I use to make something, probably I want to use the least amount of material in order to produce something, right? This is what factory lines do. They try to optimize their material usage. I can't think. Stupid J-Lo. I'm sorry, you're not stupid. Just you wrecked my mind. I don't know what to say now. But right, we are trying to either make the most money, right? If I'm trying to maximize my revenue, I'm trying to make the most money. If I'm trying to minimize my operational costs, then I'm trying to spend the least amount of money. So there's certain factors that we can think about, and using calculus with our first derivative test, or our second derivative, but usually the first derivative is going to be the easiest, we can figure out these things much easier. Okay, so an open rectangular box with square base is to be made from 48 feet squared of material. So that is talking about the area of material, right? What dimensions will result in the box with the largest possible volume? So an open rectangular box, I have to visualize in my head that I have a box that is open, right? So all that I can see inside, it's all filled in. I wonder if there's a fill. I don't think there's a paint fill. I don't know. Anyways, right, so that is a box. It is open fill. So I have a rectangular box, which means I have a base and a width that are different from each other. And then I have a height. Oh, square base. I'm sorry. I lied. It has a square base. It says square base. Square base. Square base, which means I have the two dimensions are the same, right? And then I have a height that is different, so I'll call that my y. So the volume is going to be x squared y. I also only have 48 feet squared of material, so that means 48 feet squared has to be x squared plus 4 times x y in order for this thing to work out, right? I have to add the area of my base plus the area of all my sides, and that material cannot be bigger than 48. So what this allows me to do is find the relationship between x and y. I am trying to maximize my volume, so I will want to look at my derivative of my volume, but I'm going to go ahead and get everything in terms of x before I do that. So I have y is equal to 48 minus x squared divided by 4x, and I'm going to substitute that in for y. So v is x squared times 48 minus x squared over 4x. So I'm going to simplify that a little bit, make my life easier. 48 divided by 4 is 12 times x squared, so this would be 12x. And then I would have minus 1/4 x cubed. Checking my math, making sure I did that right. 1/4 x to the 4th divided by x cubed, yes. All right, so now I want to maximize volume. So v prime would be 12 minus 3/4 x squared. So essentially I'm just trying to look for, right, when my first derivative has a critical point, right, where I'm equal to 0, I'm undefined, really the only ones that I care about this time where I'm equal to 0, then those could create my maxes or mins. So for this one, I'm going to solve for when v prime is 0. So I'll subtract the 12, move over the 4, multiply by 4, divide by 3. So that means x squared is plus or minus 16, or sorry, just 16. So x is plus or minus 4. I'm not going to take the negative width, I'm only going to take the positive. So that tells me that x equals 4. Stupid hair out of my eyes. You get a quarantine haircut. Okay, so what dimensions will result in the box? So now that I know x is 4, I'm going to substitute it here to figure out my y value. So 48 equals 16 plus 16y. So that's 32 equals 16y, so y would be 2. So my box must be 4 foot, that's a T I think, by 4 foot by 2 foot. That would give me the maximum volume for my box. Beautiful. All right. Container in the shape of a right cylinder has no top and a surface area of 3 feet squared. What height and base radius will maximize the volume? So I have a cylinder with no top, so I'm only dealing with the bottom. I can look down into the top there, so that's empty. So I have a radius and a height. So my surface area would be pi dh, so 2 pi r times the height plus pi r squared. That would be my surface area. If this was something that you needed to do on a quiz or test, I would probably give this formula to you, as well as the volume, which is pi r squared times height. These formulas the AP test will give to you. Obviously, you're going to go faster if you don't have to figure out what formula to use and you just know them. But this is something that we would give to you guys on these things as well. Okay, so those are my two relationships. My surface area is 3 pi feet squared, so I will go ahead and put in 3 pi. And looks like I need to find the relationship between r and h. So probably it would be the easiest to solve for h in this one. So I'm going to do 3 pi minus pi r squared divided by 2 pi r. So the nice thing is all those pi's will divide out. Don't lose the pi though, pi's tasty. So volume is pi r squared times 3 minus r squared divided by 2r. We can simplify that a little bit. So we have the r's will divide out, so pi r times 3 minus r over 2. So I want to keep simplifying. Might as well. I'm going to be doing the derivative anyways. So v is 3/2 pi r squared. Nope, just pi r. And then minus 1/2 pi r squared. Right. Okay. So now I need to find the derivative and find where it is equal to 0. So v prime is 3/2 pi minus pi r. I want to find where this is equal to 0. Which would be when r is equal to 3/2. So when r is 3/2, I can plug that in to find the relationship with the height, which my height was equal to this. So I have height is equal to 3 minus 3/2 squared over 2 times 3/2. You can leave it like that, or you can simplify these numbers if you want to as well. So let's do some algebra just to get us some practice in simplifying. So 3 minus 9/4 over 3. So I'm going to go ahead and divide both those by 3. So I have 1 minus 3/4. So my height would be 1/4. So my radius is 3/2. My height is 1/4. And let's check my units. Feet. So I have feet and feet. Alrighty. Moving on. Oh, I have work down there. Get rid of that work. Come on now. No cheating. Don't convert to text. Okay. So a sheet of cardboard will be made from a box by cutting equal size squares from each corner and folding up the 4 edges. What would be the dimensions of the box with the largest volume? So in order to make this into a box, I'm going to leave the top of the box open. I don't say that, but I should have said that. An open box. An open box. I stole these notes from somebody. Somebody stole my notes. Who's stealing my notes? Doo-ba-doo-ba-doo-ba-doo-ba-doo. All right. So I have equal size from corners. So this is 3 foot by 4 foot, and I'm going to cut out squares, and I will call that length x. I do not know what that length x is, but I'm cutting out squares of x by x's. All right, so what would be the dimensions with the largest volume? So my volume, if you imagine this, stop hitting convert to text. That's funny though. It converts it to a whatever face. Okay, anyways. Let's cheat and make a box like this. Right, so my height is x. Then my width, it took out 2x, and my depth, it took out 2x as well. So my volume is x times 4 minus 2x times 3 minus 2x. I'm going to multiply all that out before I take the derivative. So that's x times 4x squared. Let's see, minus 8 minus 6 minus 14x plus 12. So v is 4x cubed minus 14x squared plus 12x. And then I will take the derivative. I ain't talking to you, McKinney. So I have 12x squared minus 28x plus 12. And I need to figure out where this is equal to 0. I'm going to go ahead and divide everything by 2, and then by 2 again eventually. Yeah, so let's just divide it by 4. Okay, so that'd be 3x squared minus 7x plus 3. So let's see, does this factor 3 and 1? Has to be 3 and 1. I don't think it does. Right, so even if I do minus 1 plus 1, that would only give me 8 in the center. Yeah, this one is not going to factor. So we could use quadratic formula. I'm just going to use a calculator. All right, so I typed it in my calculator, right? 3x squared minus 7x plus 3. And I found one value to be at 0.5657, the other to be, oh, broke it. The other to be at 1.7676. So this is an instance that I need to think a little bit harder about this stuff. 1.7676 and what was it? 5657. Right, and looking at my graph too, because this is the first derivative, right, and that's what I graphed, right, notice it has negative values down here. So if it has negative values, I'm doing decreasing. So that means on my number line test, what was this, v prime and v? I was negative here. So I'm decreasing. I was positive here, increasing, and it was positive here, so increasing again. So this is the value that I want. Because it would create a maximum, right, area, what is the box, the largest volume, I need that 0.5657. If I was looking for the smallest volume, that would be my answer right there, where I'm going to do the minimum of the volume. Okay, which would essentially not even be possible. Right? Yeah, I don't think it would be possible because it would go outside of my side length, so it's inverting the box or something. I don't know what that's doing. But the only reasonable answer is my 0.5657. So x would be 0.5657. What will the dimensions of the box be? So feet, and then if you do 4 minus 2 times that, by and 3 minus 2x by 2.869 feet by 1.869. And there would be your dimensions of the box. It doesn't matter the order of that stuff. It's all going to be the same deal. Okay. Construct a window in the shape of a semicircle over a rectangle. Okay, I will do that.
Yes, sir, I will do it.
Okay, so there I have my window. If the distance around the outside of the window is 12 feet, what dimensions will result in the rectangle having the largest possible area? So in the rectangle, notice it says in the rectangle having the largest possible area. So the area is xy. If I call this x and I call this y, my semicircle has a radius here, r, of x over 2. So the distance around the outside of the window, right? So I'm talking about this distance here is 12 feet. So 12 feet is equal to, the circumference of a circle is pi times the diameter, or 2 pi r. So since I'm half of a circle, it's just pi r, so pi times x over 2, plus x plus 2y. All right, and that would be my perimeter, essentially. So I have two equations. One of them relates x to y. So I'm going to substitute in for this y, so I'll need to solve for that one. So I'd have 12 minus pi over 2x minus x, all divided by 2, equals y. So I'll substitute that into my area. So I have 6 minus pi over 4 x minus 1/2 x, and then times x, so my area is 6x minus pi over 4 x squared minus 1/2 x squared. So if I do my derivative, that's 6 minus pi over 2x minus x, and then I can solve for when that is equal to 0. There's only going to be one solution. So I want to move over that 6, factor out the x, and divide the negative pi over 2 minus 1. So I have negative 6 divided by negative pi over 2 minus 1. And that is 2.3339. All right, what dimensions will result in the rectangle having the largest possible area? So if x is 23339, then I can substitute it back into this one to have the y so 12 minus pi over 2 x minus x divided by 2. So 2.3339 by 3. That would be the dimensions that would give the largest area. All right. We are getting there. All right, let's get after it. Stop wasting my time. Yeah, I'm still on the call. I should get off the call. It's 11:39. You guys are allowed to talk to me, I promise. The more you guys talk to me about stuff, the better we will do. For those of you guys watching the video, at least. Yeah, that's good. Okay, Consider the parabola of this. Determine the points on the function that are closest to the point 0, 3. So what I want to do here is minimize my distance from the point 0, 3 to my curve. So if I envision this parabola in my head,
There's my parabola, he's so pretty.
here's my point 3, 3. So probably, right, straight up and down the distance is 3 units. That's 3 units right there. But most likely there's going to be a distance here and there where my distance is smaller. So if I think about this, right, the distance equals x squared plus y squared, right? That's just Pythagorean theorem. So the distance is the square root of x squared plus y is 6 minus x squared, but it is to the point 0, 3. All right, so I need to do the difference between these 2 points, because this is x and 6 minus x squared, and that is just the point 0, 3. So the difference in my x's was 0, or sorry, just x, and the difference in my y's is 6 minus x squared minus 3 units squared. All right, that would be that side of the triangle. You guys okay with what I mean here?
Yeah, no, what are you talking about?
Right, this distance, this length, is whatever this point is minus 3. And then the x distance, the distance right here, is just x, because it's just how many units it is away from the y-axis. Okay, so now that we have this, we can minimize this distance by taking my derivative and setting equal to 0. So the distance prime would be 1 over 2 root all of this junk, so x squared plus 3 minus x squared squared times the derivative of the inside, which would be 2x plus 2 times 3 minus x squared times negative 2x. Right. So I'm going to multiply out my numerator. Right? And then I want to figure out where this equals 0. So I want to figure out where 2x minus 12x plus 4x cubed is equal to 0 in order to minimize here. So 0 equals, that would be negative 10x. So I'm going to factor out a 2x. So 2x squared minus 5. So 0 could be one of them, and so would x squared equals 5 over 2, so x equals plus or minus root 5 over 2. Since I don't have any limits on my domain or anything, that just means that root 5 over 2 is also one of the positions, positive and negative. All right, so I have the point 0. Determine the points on the function. So I have the point 0, 6. I also have negative root 5 halves. And let's see, it would be 6 minus x squared. So 6 minus 5 halves. And positive root 5 over 2. And then the y value would stay the same. All right, and then thinking about these points, right, those are the points that matter, but I do need to test around them still. So negative 5 over root 2, 0, and positive root 5 over 2. So let's see. Root 10 divided by 2. So that should be, root 5 over 2 is somewhere between 1 and 2. So negative 10, 1, 1, 10. So let's see, I'm talking about d prime and d. So let's see, if I put in a negative 10, it's going to be a negative times a positive, so this will be a negative. A negative 1 will come out a positive. So that is for sure minimizing at negative root 5 over 2. And then if I put in positive 1, that comes out a negative. So this is no bueno. And then positive 10 would give me a positive. All right, so I'm going decreasing to increasing to decreasing to increasing. So this is kind of a relative max point there. So that's why I do not want to include that point at 0, 6. Alrighty. We got 2 more, 3 more. Getting there. Trying to give you guys some good options. Okay. Rancher has 200 feet of fence which to enclose 2 adjacent rectangular corrals. What dimensions should be used such the area enclosed will be a maximum? So the area is 2x times y. And he has 200 feet, which means x times 4 plus 1, 2, 3 times y is kind of my relationship between x and y. So I will, is there a better one to do? I don't think so. No, they're both going to be non-divisible. So I'm going to do 200 minus 4x over 3 is equal to y. So a is 400x over 3 minus 8x squared over 3. Right, and that's putting this in for y and then multiplying things together. So 2x times 200 will be 400x, and 2x times negative 4x will be negative 8x squared. So then I can take the derivative. So that would just be 400 thirds minus 16 thirds times x. Solve for when it is equal to 0. So I'll subtract over that 400 thirds, and I will multiply by 3. So those will divide out, and then I will divide by 16. So what is that? 5 would be 80. So 25? Yes, sir. So x is 25. And if I look at it on a number line, it should map out because it's my only option. So a prime and a. So let's see, if I'm less than 25, it's going to be positive. If I'm greater than 25, it's going to come out negative. So yes, that is a maximum, and I'm maximizing my area. When x is 25 feet, and then y must be, so 200 minus 100 divided by 3, 100 over 3 feet. And that would be my answer. Alrighty. A company's revenue selling for X thousand of items is given by this function, where R is measured in millions of dollars. Millions of dollars. Find the value of X that maximizes the revenue and find the maximum revenue. So I'm looking for R prime. So do your derivative slowly. So low d high. So low is x squared plus 35. D high would be negative 2x plus 35 minus high d low. The derivative of low is 2x, so 35x minus x squared, all over low squared. All right. The denominator is never going to be equal to 0. That's not possible because it's squared. So really, I'm just trying to figure out when the numerator is equal to 0. So I'm going to go ahead and distribute everything. So negative 2x cubed plus 35x squared, and then minus 70x and 35 squared. I don't know, 1075 or something. 1225. I shouldn't run that. So plus 1225. And then minus 70x squared plus 2x cubed. All right, combine like terms. So I lose my 2x cubes. That's nice. So I have 0 is negative 35x squared minus 70x plus 1225. I can divide by 35. So I have x squared minus plus, I'm just kidding, 2x, and then minus 35. Let's see, things that multiply to be 35 are 5 and 7. So this must be negative 35 times x plus 7 and x minus 5. I'm probably not going to take the negative value, it must be the 5. Right, because I can't sell negative items. So x equals 5. 1,000 items. And then my revenue of 5 would be a big number. So 35 times 5 minus 25 divided by 25 plus 35. So 2.5 million. Dollar bills. All right. All right, last one. So two positive numbers, x and y is 3. So x plus y is 3.
Hi.
Hello. All right. Sorry. I got pie. Thank you so much, Carolina, for watching that. That was so nice, so sweet. So if the sum of two positive numbers is 3, so x plus y is 3, right? That's what the sum is. And I also know that they have to be positive numbers. What is the maximum value of this? So I'm just going to say value is x cubed plus 12xy. And as you've seen all along, right, it is very nice if I can differentiate in just terms of one thing. So it really doesn't matter what you substitute for. I would probably choose y because it's going to make the least amount of work, because then y would be 3 minus x. And if I make that substitution, then v is x cubed plus 12, keep doing that, x, okay, times 3 minus x. So the volume, the values, v stands for value, would be 36x minus 12x squared. Right, and then I will take the derivative so that I can find the maximum value. So 3x squared plus 36 minus 24x. I'm going to rearrange and factor out a 3, set it equal to 0. Or 8. And let's see, we have 0, x minus 6, x minus 2. So x equals 6 and x equals 2. However, I know one of these is my only solution. My only solution would be 2, because they have to sum and both be positive and be 3. So that means x must be 1, or sorry, x must be 2 and y must be 1. So the maximum value of this would be 8 plus 12 times 2 times 1 plus 24. So the max value that I could have for this thing would be 32. Okay, that is it. So again, we're just using first derivatives to figure out how to maximize and minimize things. This can be very challenging, so good thing you guys have this homework over the weekend. Other than that, if you have any questions, as always, please just let me know.